Okay, so I'm here with Luciano Resende, and he is Brazilian, amigo meu. And he actually sacrificed his lunch break for me, I discovered, because it's 12 p.m. in San Francisco. Is that true?
Yeah, but no worries. I've been on meetings since 7 a.m. It's fine.
Oh, okay, poor guy. So you are a colleague of mine, and you are very, very involved in the whole Jupyter ecosystem, and you are kind of the main brain behind Elira AI. Is that correct?
Yeah, we have been working with Jupyter for a little while. We started Enterprise Gateway, and now we are starting Elira on the Jupyter ecosystem. Correct.
Okay, cool. So can you maybe summarize for our listeners what Jupyter is, in case they didn't hear about Jupyter?
Yeah, so for those that are not aware of Jupyter, it's a Jupyter Notebooks provides you an interactive development environment. It allows you to start putting code together, documenting it all in the same place, and have also like a very interactive session where, for example, if you're analyzing data, you can submit a piece of code that reads some data, you can start plotting it, and you can start playing with the data till you feel comfortable with that to then start building your model, your analytics on top of that. It's a very flexible and has been very used initially on the academia community, but more recently we have been seeing a lot of that on the enterprises. Everybody that is using or doing any ML or AI pretty much uses notebooks one way or another.
Okay. Do you have an idea why Jupyter is so popular? If you compare, for example, with RStudio or PyCharm or Spider?
I think when we look into, for example, IDs, you sort of like don't have all that flexibility in the sense of like being interactive versus non-interactive, putting everything together, but also it's easy to uh, um, share with others what you're doing. So like, for example, a program you can read the code, let's say if you share with someone on GitHub. If you're sharing a notebook, you will see the code, you will see the results, you will see all the plottings. It really gives you a much better way for understanding what that is without running. Or if you run that interactively, you can see things that uh, uh, and play with things without having to run all of that. So, like for example, if you have a program that you run on Python, for example, and loads a terabyte of data, you have to load that every time you execute the program if you're running on IDE or something like that. But if you have a notebook, then it's more like you load the data and you can play with pieces of that data without having to load that every time. You have when you're running on the notebook, you have a session, a stateful session that on the server has some of the resources or the previous code that you executed and then allows you to play with that. I think those are some of the characteristics that make notebooks really interesting these days.
Okay. So it's about simplicity and collaboration mainly, no?
Correct. It's very powerful as well in terms of like language. On the notebook, you go there, access that via URL, and pretty much you have your environment, everything that you need to build, it's there. And you can choose what language you want. Like if you're a Python script developer, you can have a Python kernel. The kernel is abstract, and we have pretty much all of the languages supported today. So if you prefer R, if you prefer Scala, if you're not an engineer and you want to do Scala and Java, all of that is available in the simplicity of the notebook and providing you a very powerful environment even so.
Okay, so you mentioned kernel. What is a kernel, a Jupyter kernel?
So a kernel, yeah, that's a good question. A kernel is what abstracts the execution of the code. So like when you have a cell of the notebook and you type something there and you then press to run for that cell, what is happening there is it's sending that code to get executed the kernel. The kernel abstracts kind of like the execution engine, and then you have multiple kernels which supports different languages or different scripts.
Okay, so what's the core ingredient if, for example, I would love to implement a kernel? What do I need to do to provide? Is it a set of APIs you have to implement?
So Jupyter talks with kernels via a protocol, which is based on sockets. So you have to, a kernel implements the control on the life cycle of those ports, which is the, let me remember the name of the protocol, the zero, I forgot the name, but like really, when you're building a kernel, you have to support the messages, the flow through those sockets, and internally then executing with the language that you are sort of like supporting there for that kernel.
Okay, so the server-side component of Jupyter Notebooks is talking to the kernel, and the Jupyter Notebooks, let's say single-page application in the browser, is talking to the Jupyter server via WebSockets. Is that correct?
So the browser is just a visualization. It talks via HTTP to the Jupyter server. The Jupyter server then communicates using the protocol, the ports, the socket to the kernel.
Okay, so that's clear. So can you maybe put the names Jupyter and JupyterLab and JupyterHub into perspective?
Sure. So I would say not only Jupyter, so we have Jupyter Notebooks, and when we say the classic notebook is kind of like the initial UI that we had, and that is a single page UI that gives you the friendly notebook interface that we know from a long time. More recently, folks have started shifting to work on what is called JupyterLab. So JupyterLab is the new interface for Jupyter Notebooks. It looks much more like an IDE. It allows you to work on multiple documents at the same time. So it has like tabs, and it gives you a lot more flexibility in terms of like how you can arrange. So if you're working on a notebook and comparing the results with a different notebook, you can put them in parallel. So it's a much more flexible interface, and it's going to become the new interface for notebooks. As for JupyterHub, so Jupyter Notebooks, they are an evolution from kind of like the IPython kernel, sorry, the IPython console, which then started bringing a user interface, a web interface into that. And what happened to that is, because of the evolution, they had some limitations, so it's kind of like a single user environment. JupyterHub allows you to bring multi-user to Jupyter Notebooks. So what it is sort of like a reverse proxy that authenticates you or the user, and then redirect you to a unique environment for a Jupyter notebook. So it can be a classic notebook, it can be a JupyterLab, you can define that in the configuration. But then once you go through JupyterHub, it will manage the life cycle of an environment for you, where you can start doing your analytics on a notebook environment.
Okay, and this is the point where Jupyter Enterprise Gateway kicks in. Is that correct?
Jupyter Enterprise Gateway can kick in both ways. What we see today is that your laptop is not enough for doing kind of like a big data analytics or some of the AI workloads that we see, and you need more resources that are available away of your computer. So in this case, Enterprise Gateway will enable your kernels, which we mentioned what it is before, the engine part of it, to run remotely and to run distributed. So let's say you want to analyze some big data on a Spark cluster. Enterprise Gateway allows you to do that. Let's say if you want to do some AI analytics, some AI model training on a Kubernetes environment. Gateway allows you to do that only using the resources that you need, sharing, for example, GPUs and all of that to that workload, and then sending back the resources to the server when you're finished with that, which is not possible with what we call vanilla notebooks, which will use all the resources that are available only locally.
Okay, so that actually means I can, for example, create a multi-user environment using JupyterHub and connect this multi-user environment via Enterprise Gateway to a Kubernetes cluster. And then only when a data scientist is actually running a notebook on a specific configuration, those resources are allocated on Kubernetes, and after that, it's freed.
That is exactly what happened. So it's much better in the sense of like resources, because you might be doing a notebook that only plays with a little bit of data, and another notebook that is actually doing an AI and requires a GPU. So you can use those resources just when the notebook is running, and then get them deallocated. Yes.
Awesome. Okay. So and then let's come to Elira AI. So that's basically chronologically the next project you have been involved with, or you have basically created.
That is correct. So Elira is, if you know JupyterLab, Elira it's a set of extensions on top of JupyterLab. It aims to help data scientists, machine learning engineers, and AI developers through the model development lifecycle complexities.
Okay, so that sounds so far as a marketing teaser. Can you tell me what's exactly in the package?
Oh, sure. So initially, what we have on Elira is a set of like extensions to JupyterLab. So we have a notebook pipeline visual editor that gives you the ability to start visually dragging multiple notebooks into a canvas, building a workflow with that, enabling different, you can set different properties. So like if you're doing a workflow where you're using, let's say, pandas for ETL, and then a next notebook, you're training a model using so you can select the different environments that you need, and then flow different maybe inputs and outputs between the notebooks. And all of that is kind of like in a visual way. You also have the ability to run notebooks as a batch jobs. And to a certain extent, if you see a pipeline as a multiple notebooks running as a node job, as a batch job, the ability to run notebooks is basically a pipeline with one node. We have also Python script support. You can edit the Python script on your JupyterLab, and then directly from there execute it locally or using cloud resources. We also have integration with the notebook versioning using Git, and table of contents has also been integrated, which gives you the ability to navigate into big notebooks, but also into scripts in a much better way by providing a table of contents on the left. And last but not least, we also have reusable configuration for runtimes. So we notice that when we integrate with different components or different external pieces, we need to store some kind of like configuration to enable us to access that. And this is sort of like a metadata for accessing those runtimes.
Okay, so it's a set of, let's say, plugins or a collection of plugins which address development and also deployment. Is that correct?
I think it's gonna go into that direction. A lot of the things today are more towards the development. You can do deployment scenarios if you consider kind of like running this remotely on a let's say a Kubeflow pipeline environment. But I think we will get to stages where we're gonna have more kind of like a model deployment also more integrated into Elira as well.
Okay, so maybe we have to clarify some terms here. Would you mind to clarify Kubeflow and maybe even Kubernetes?
Oh, sure. So Kubernetes is a environment that is getting very popular these days for doing microservices. So you build multiple Docker images, and then you are able to deploy in those as an applications built from microservices. Kubeflow then becomes a more AI tailored set of components to help on the machine learning and AI model lifecycle. It runs on top of Kubernetes and provides you a lot of like the more specific AI and machine learning lifecycle components that is needed for your application, your model. And then Elira leverages a lot of that, although Elira is not necessarily to only runs on that. For example, integration with Kubeflow will require that. JupyterHub also has the ability to run on Kubernetes. So if you're really looking to a full, complete set of components running together, more like into a more real use case scenarios, you will want to have a Kubernetes cluster. You will have a Kubeflow pipelines deployed, and then you have JupyterHub and Elira in place as well steps in a self-service analytics platform.
Okay, so the key term here is self-service analytics platform, I think. So just to paraphrase what you said, so Docker is the abstraction of, let's say, a container, and Kubernetes is the orchestrator engine on top of that. And then Kubeflow pipelines makes use of the orchestrator as a runtime. And each data processing step can be composed of different type of images. For example, you can have a Spark image initially for ETL, and then you have a TensorFlow image for the model building, and then maybe you have a trusted AI image for bias assessment, for example, and maybe then another stage for deployment. Is that more or less correct?
That is exactly.
Okay, so you mentioned deployment. In which direction are you thinking you want to go? Is there something around KNative, or what's your plan there?
Yeah, I think we want to make it simpler, and we want to go with what is being used in the community, which is KNative. So I think in the future we will see more Kubeflow components being available on the Elira canvas, and then you will not need to have to code your deployment into a notebook. You will be able to just say, okay, this is a deployment node, and then configure some metadata properties, which will take care of doing the deployment of your model. So that's exactly the direction. We want to make it easier for the data scientists to be able to deploy their models through those steps.
So for as a practical example, a TensorFlow stage would create a model file, store it to object store, and then a deployment stage would then pull that file, model file, and make it available to consumers via gRPC or REST.
Yes, exactly.
Okay, that's cool. I mean, you said you can directly run Python scripts and deploy them to the cloud from Elira. I assume that's outside Kubernetes, or how is that working?
The Python script supports leverages Enterprise Gateway. So what we do is we launch a Python script kernel, and we send your script to be executed. So it can be executed locally as well as on the cloud.
Okay, so I think Enterprise Gateway alone is a really cool thing already, because you have your local IDE, and then you're not constrained anymore. You don't have any resource constraints anymore, because it's just a drop down where you select the resources you need, and then you just execute it. And after your execution has finished, the resources are freed again. So it's very elastic, no?
Exactly, and you get all the results back locally on a kind of like a panel for you to evaluate what was the output.
So that means actually you don't see the difference from a local to a cloud or
No,
remote.
it's completely transparent for you.
Okay, that sounds cool. So let me ask you about your mode of working. So I have joined the Elira community calls twice. So I noticed that you are really bound to open source tooling. So the transcript, or let's say the protocol of the meeting, for example, you on the fly code in Markdown, and that is made available to everybody. So how do you organize yourself? Is there some central entity like you who decides what's going to be implemented, or is that more chaotic, or everyone has his own vote?
I don't think it's like I would decide. We really, I mean, we are an open source project, and I think what I really want to build is a community around Elira. We are very open community. I've been working on open source for over 10 years, and I really like the ability to like have a lot of like different views on particular areas and get contributions and different scenarios into the project. I think currently, because my involvement and from the creation of the project, I think I have some ideas, kind of like a medium to long term that I want to implement. And but I think the community and the team working on the project at the moment is really open to uh, um, uh, different ideas, different directions, and things like that. We really would like to get more people contributing. We really would like some different scenarios working into Elira. So that's sort of like how we plan to move ahead with Elira.
So what would you prefer? People who code and implement features, or people who test, or people who tell you what to do? like me. that's my specialty.
We welcome all different parts. I mean, and not only that. I mean, we know we don't have a very detailed documentation, and we are sort of like a new project to that extent. I mean, if you look into, let's say, Kubeflow, Kubernetes, those projects are there for several years. I don't think we have a year from when we started doing the first pieces on around Elira, and we just open sourced that a couple months ago. So all the different areas from documentation to telling us what to do is very welcome. We also have a lot of like issues that we know we want to take implement that at some point, but we don't have the resources at the moment, where we mark as help needed, or for folks that are just coming to getting experience with open source. We also have some of the good first issue for folks to just start contributing. So we welcome all of those contributions.
Okay. And what's your mode of work? So you told me you are in conf calls since 7 a.m. So when do you have time to code or work for Elira?
Usually these days, afternoon to mornings are a good time for coding, where I get a break. But usually it's not that heavy on calls. I think mostly 2 days a week for some reason, all the calls concentrated. But the other days I have more flexibility, and I'm able to spend more time on coding as well.
Okay, so you are working mostly, or let's say the calls you have mostly in the mornings, because I have all my calls in the evenings, no, because I'm in Europe time zone.
Yeah, no, my to I think to accommodate different time zones, I think most of my calls are in the morning. The days that I have to get early, I think I start 7 a.m. and then close to 2 o'clock Pacific time. We don't have other calls. Unless once in a while when we are actually talking to someone close here, particularly these days where we are not in the office, But otherwise, is up to 2 o'clock, and then I start being freed up.
Okay. Yeah, for me, it's the other way around. So I start my calls at 2 p.m. They go up to around 10. I try to stop at 10 p.m. And in the morning, I'm free, so I have my head free for working. Yeah, that's cool. So you are now at home in the flat in San Francisco?
Yeah, it's actually San Jose, close to San Francisco, and I'm home. Yes.
Okay, so you are working from home exclusively at the moment because of COVID-19, or are you used to work from home?
No, so mostly because of COVID. I would go to the San Francisco office 2 or 3 times a week, and then there is also the SVL office, which is close to home, and I would go there. But then more recently, I think pretty much from February, I've been working from home.
Okay, so for those who don't know, SVL stands for the Silicon Valley Lab, and the San Francisco office is, I think, in Market Street, no?
There is one in Market, and there is one in 505 Howard, which is the one that I go to. That is the
Okay.
IBM Watson West office.
Okay. I think that's pretty cool because you have a good view. No, it's like
the views are nice. The 425 Market Street has a better view because it on the top floors you can get the view to the Bay Bridge, so it's pretty nice.
So how do you go there? Do you have a car or do you use Uber?
I drive. It's a long journey. It's like a trip. It's about, if I drive and I don't get heavy traffic, it's about an hour and 15 to an hour and 20 minutes. So being able to stay home saves me about 3 hours a day. So that's good.
Yeah, and it saves the planet a lot of CO2, no?
Correct.
Okay. So the rest of the team, are they also between San Jose and San Francisco, or are they more widely spread?
So they were all on this area between San Francisco and San Jose, except Kevin, that was a little bit further after San Francisco. But now we had our 2 new teammates, Carla and Martha, and they are remote. They did an internship with us. They did a really good work last summer, and we hired them after they finished school this year. So they're doing a great job, and then we made a plan to hire them in a different city, but we all working very well on the community these days.
Yeah, okay, so remote working is not a really big problem. One thing I forgot to ask before, can you also tell us what KNative exactly is?
KNative, as far as I know, and I have only been involved with that a little bit, is a ways to start deploying the models into a more native Kubernetes environment. And I think it does similar to sort of like serverless, where it does not necessarily stay with that pod or that resource is up every time or all the time, and it will basically upon requests be able to scale and instantiate new instances to respond to your query to that model.
Okay, so it's a technology coming from the serverless and from the microservices world, I assume.
Correct. And it's being tailored more towards machine learning and AI.
Okay, yeah, perfect for model serving then. Okay, good. Another question. So I mean, don't get me wrong, I like all the features of Elira AI, but I somehow fell in love with the pipeline editor because for me, it just merges 2 worlds, the coder world, the notebook-based world, and the drag and drop low-code, no-code world. And you said it's generating Kubeflow pipeline specifications. Can you tell me a bit about the internals? So how is this? Let's start with one question, one after the other. So the pipeline editor, did you implement the UI yourself, or did you use something already existing?
So these are actually very good questions. So in IBM Watson Studio, we had this component called Canvas. And Canvas gives you kind of like the basic components to build the flow on the UI. So as part of Elira, we have open source the Canvas, and it's now called Elira Canvas. And that's what we use, like when you drag and drop your notebook and you see the component there that is using the Canvas. Canvas then produce you a blueprint, a JSON file with the specification of the flow, which we parse. We submit that the runtime parse that and gives you a sort of like a data representation of that. And then we have internally processors that are for each runtime that we support, gets that definition of the pipeline and produces what that specific specific runtime is expecting to be able to execute those flows. So the flow to a certain extent is that in terms of like visual pipeline, submit the definition, we parse that, and then we create the specification based on the runtime that you specified.
Okay, and in the case of Kubeflow, this is this weird-looking Pythonish DSL, which Google specified, no?
Yeah, so we have Kubeflow, which is using the Kubeflow pipelines DSL. We sort of have a alpha version for Apache Airflow as well, which is also using, they also follow the same pattern of having a Python DSL, but it's a completely different DSL, but yes.
Okay, so that is open architecture by design, no? Because you have a open source visual editor which produces JSON, and that's, I assume, capable of round trips. So it can parse the JSON and create a visualization, and you can change the visualization and save, and then you have modified the JSON. No, that's correct. Okay, so that's something closed in the sense of doesn't have dependencies to anything else. And then from there, you have a translator somehow from this into specific execution environment definition languages. And then this transformation is then basically used to deploy it to the engine.
That is correct. And I think one thing that I missed is within this flow, we also identify dependencies. And for example, let's say you have a notebook that imports a local JSON file or uses a local CSV. When we need to execute that remotely, you need to have that file available as well. So we also package that and make that available into object storage so that when you are executing that node, we will make those files available on the runtime remotely as well.
Okay, so that's happening when you say run and then deploy to Kubeflow. A lot of things are basically happening now. It takes some time, and that's one part. Okay, correct. That's cool.
What are you working these days in? I know you've been doing some of the COVID analytics playing on top of Elira, but what are the areas that you're working on these days?
Okay. Yeah, see, I have been working with Frederick Rice, which is a fantastic data scientist. No, he's awesome. So I've been mainly supporting him in getting his stuff running on top of Elira. I mean, I started also with basic analysis. So what I did for COVID-19, I'm a little proud of is that I came up with a measure which actually tells you the percentage of people infected in a specific country. And what I do is I take the number of deaths in contrast to the number of cases, because they, I believe, are more accurate. And then what I do is I multiply with 200, because the more or less confirmed fatality rate of COVID-19 in the industry countries is 0.5%. So I get more or less an estimate of the minimal number of cases, because there are, of course, more. And what I then do is I use the population per country, and I compute the percentage of infected people. And they are then either currently infected or dead or recovered. And then I know we can project the herd immunity. So what I then do is the cumulative sum, and you see the percentage of the people infected per country. And that's something. For example, Netherlands is leading here with 12%, And I'm using Elira here to create that flow because it's a relatively complex flow with like 5 or 6 notebooks. I pull the data directly from an open data source. So I'm using the EU open data. It contains all the countries, and Frederick is using the Johns Hopkins data. So the numbers in the EU dataset are lower because only the confirmed cases from the health, how is that called, from the Ministry of Health is used, and I think the Johns Hopkins data includes more sources. So I would say you get the bare minimum of people affected from the EU data set.
You get only the official data. Okay.
Yeah, that's only official data. Correct. And Frederick is doing something different. So one thing what he does is trying to model. I try to model as well, but what I usually do for time series, I'm using the LSTM models, the long short-term memory neural networks, which usually work quite well, but I really failed on the COVID-19 data, and I didn't know why. And Frederick explained to me that it's basically exponentials, and they are so sensitive to the parameters that slight changes completely change the trajectory of the exponential. So what he did is using composite models of exponential and sigmoidal models, and he was really good in modeling all those different counties data. So that's something he integrated. And what we now have is a collection of notebooks and a collection of pipelines. And by the way, they are open source. No, I mean, you know it. You helped us in getting them up and running on Elira, but it's really cool because they are now part of the open source community as well. A nice showcase for Elira, and also something which actually is like, I think it's used by university now for the students for further developing those. So that's one thing I was occupied like a couple of weeks before, and then I somehow slipped into the COVID tracing business, or let's say in the open source world of COVID tracing. So there are a couple of open standards for privacy preserving COVID-19 tracing, and one of those is called DP3T, and I got involved during a virtual hackathon. So I'm not a big fan of hackathons anymore because I just went to too many the last years, so I stopped this like half a year ago. But then I thought the COVID-19 hackathon is something I want to do. It was virtual and at the weekend, so I joined, and one team created an app which was called vTrace, which actually used privacy preserving cryptography and Bluetooth Low Energy. So that was the first prototype, and with that project and other project, the DP3T standard evolved. And that's, by the way, now a standard which is used by the German, the Swiss, the Austrian, the Finlandian, and the Australian government for the tracing app. And in that work, I created a privacy estimator tool or something. So it's a Raspberry Pi Zero W, which traces the Bluetooth Low Energy beacon advertisements. And I discovered a little privacy issue, which actually allows you to fingerprint Android devices. And that's also present in the Google Apple API, by the way. But it's important that we know it, no? Because for the tracing applications, it's very important that at least 60% of the people use it. And I heard in India and in other Asian countries, it's mandatory. So that's also a solution, but I don't know if you are aware of that, but Europe is very, let's say, respectful to the rights of the individual, and still, who knows what happens. And so you might have heard about GDPR, which causes a lot of trouble sometimes, but it's a very good thing in my opinion. And also it will be voluntary in the EU, and if we don't get the 60% usage, it's useless, no? So it's very important that the privacy is guaranteed and we are really open and honest to the users. When this is finished, I'm hoping to come back to data science again, and it's all around architecture and strategy now, because My job here is to define reference architectures for our clients, and I need to tell them what to do. No, so I go to clients and I'm in discussion with them about their, let's say, I don't like the word big data because it's an old term, but it's more or less their, let's say, their AI pipeline. No, let's say their AI ecosystem. What they want to use, that they can stay open, that they support their users best. And I'm definitely always mentioning Elira there. And the more major it gets, the more confident I am. I mean, Kubernetes and OpenShift is definitely becoming a very, very interesting topic because it's open, no, and it solves a lot of problems. So the room for, let's say, closed source proprietary solutions is getting smaller and smaller there. So a lot of companies I'm talking to have this open source first principle. If they cannot solve it with open source, they are okay with closed source, but they always check out what's out there. And I think the model of having very stable and standard open source tooling where you have multiple vendor support is going to be the way forward. No, so we are like working at the best time in the best area at the moment. We too, no?
Yeah, it looks very exciting. Some of the projects that you're doing. So I'll probably reach out to you and look into more details. That sometimes seems very interesting, and hopefully we'll be able to visit you sometime after all of this is gone and we can start traveling again. I really enjoy Switzerland and all the beautiful scenery there. So it's really something that I'm waiting for.
Okay, so when the travel ban is over, I'm pretty sure I will get a Swiss client who's very interested in Elira and will go forward with a large POC, and then we will have budget to fly you in, definitely. So I will work on that.
That's really good.
Yeah, another thing I forgot to mention is you might have heard that I'm a Coursera instructor, so I have like 7-8 courses now. And I think my courses crossed the 100,000 learners mark, and all our courses. So now I'm working together with a team which is responsible for all the courses on Coursera and EDX and all the other channels. And I think we are now on 1.1 million learners with all the courses. But it's something I just cannot do anymore full time. No, I was like doing one course and then 2 and 3 and 5 and 7 and so on. So what I now have is a team for the course production and a team for maintaining the course. So they are answering the questions in the forum, and I get my head free now. It's more strategic now. So I'm more or less deciding what courses we need, what courses need to be updated, what parts of the content need to be updated, and I have others doing that for me, which is very nice because otherwise I'm just would have done courses all day long, and then that's not fun. No, I want to work on the things.
I know you had a few, but you didn't know you had all of that and all of the number of learners. So it's pretty good. Congratulations.
Yeah, thanks. Yeah, it was growing like fast, and during COVID-19, it was like doubling. No, the courses are at least, yeah. Or some it went up from like 1,000 learners per week to 3,000 or 4,000 learners per week. So it's incredible. And yeah, that's fun, but yeah, I'm happy that I can delegate so much of the work to others now and concentrate on the more interesting stuff. Okay, cool. I think you have another meeting in 8 minutes. So, yes. So you have like 8 minutes for your lunch. Thanks so much for taking time for me.
Oh, no worries. And, thank you. It's very good talk to you.
Yeah, let's do an update talk once Elira has progressed a bit.
Okay. Thank you. And see you soon. Okay. Bye-bye.
Yeah, bye.